Welcome back. In this lesson, we're going to look at igneous rock features. So while a patch of rock is melted, while it's magma, while it's under the ground, if it doesn't come up through as a volcano, then it is possible that it will never be a volcano, that rock will simply cool off again and become solid again once it had been melted. And so these features can, for either be hidden forever as they're still under the ground, or if you have erosion, these features can be uplifted by mountain forming in such a way that you can see these structures. And these structures were at one time magma, but they never made it out as lava. So they're very hard rocks, and they can form huge mountains, very distinctive mountains. And some of the very distinct mountains that we have are actually features that formed under the ground and were under the ground for a long time. So let's look at some examples. Melted rock that never made it to the surface. So it never came out as lava. It was only magma. So magma is melted rock, and what it touches can melt other stuff. So as it's squeezing its way in the rocks that it lives in, it could melt those rocks and make those rocks part of the magma. It could also squeeze through rocks. So let's say there's cracks in the rocks. It can squeeze through those cracks. And the features that they form may never be discovered. Or after a long time, if the top of the surface erodes down to show some of these features, since these melted rocks are very, very hard, they usually last. So because that they last, you can see these features in many areas where this material has been uplifted due to other tectonic activity. So remember, intrusive means it never made it out. So we're going to look at some of these features. They have different names, and there's various reasons why that you would have melted rock. You could have had two plates that crash into each other, and it forced the crust down further into the mantle, which made it hot enough to melt a big patch of rocks. There's various reasons of why you would have some melted rocks, but once they're melted, you have magma. Then that magma can form structures simply by squishing through and breaking through other rocks that are there. Okay, so the first one we're going to look at is plutons. And a pluton is anything that essentially, and it's still intrusive, so it never made it out as lava, but a pluton is usually some big kind of a blob underground. All right, and there's a couple different kinds of plutons. The biggest kind of plutons are called batholiths, and batholiths are huge, okay, and they were all melted rock at one time, and then for what reason the hot spot moved, and then all of that rock slowly cooled back into solid rock again. And so the batholiths are the biggest ones. A lot of times you'll have a batholith inside a mountain. Like at the core of that mountain, you're going to have a batholith. I can't say that without lisping. Batholiths. All right. Smaller than that, but the same kind of idea, is called a stalk. So a stalk essentially is a melted patch that's come up through various layers of rocks. And these are usually very deep underground. Now, the next feature is a laccolith. So you have a batholith and a laccolith. A laccolith has come up through a crack in a rock and then bulged, but didn't melt its way back down. So it's sitting on top of some kind of a ledge and then is balled up, okay, like a mushroom above it, so it has a flat bottom and a round top. That's a laccolith. The more predominantly is a sill. So if you have oozing hot rock that cuts up through a crack and then sits along a layer of rock, that's called a sill. Like a windowsill is flat, a horizontal. So this is a horizontal layer of melted rock that's oozed up, usually through some kind of a sedimentary rock that's in layers. dikes are the pipes that go up to a sill. So the crack in the rock where the melted material goes up through is called the dike, and then the sill is the horizontal. And you can have various large ones and small ones as it simply runs along a horizontal rock, usually sedimentary rock. You're going to have these sills as it goes through. And then the dikes can either be vertical or at some kind of an angle, wherever the crack happened to be, and then the melted rock goes up through the crack. A lot of time it's the dike that will form the vent of a new volcano. So enough hot rock squeezes up through the dike in such a way that it melts the rock above it. The dike gets bigger, bigger, bigger. Eventually, it makes it to the surface. As soon as it's at the surface, then that's a vent. So the dike becomes the vent of a volcano. So there's various, like we said, various reasons why that you would have melted rock, different tectonic reasons. But then once these plutons, once these large areas of melted rock, if they were to ever become exposed, these are really, really hard rocks, and so they don't weather very much. So the softer rock, maybe a sedimentary rock that happened to be in, is softer. That soft rock will erode first, and then this hard plutonic rock, which was solid, it's one big solid rock, it's huge. This is, by the way, what you would carve in. Mount Rushmore and all of these large-scale monumental carvings are all done in batholiths, or at least stalks.